In this WellSeeker Pro training video, I will be introducing anti-collision. We'll take a look at all the various inputs that affect anti-collision and the different outputs available within the software. So the first thing that we'll look at is the anti-collision settings, which can be accessed at operator level in the database tree. So at operator level, we right click, we select properties. The bottom section of this dialog specifically relates to the anti-collision settings. It's very, very important that these are set up correctly, as they have a direct impact on the anti-collision output. Anything input incorrectly here will render your anti-collision outputs meaningless. So we'll go down through the options we have available. We've got some drop-down menus here. So scan method, 3D closest approach is the default, but we have three additional options: travelling cylinder north, horizontal scan. Probably one of the most important things you need to understand here is when looking at the travelling cylinder plot, you need to ensure that the scan method is selected as travelling cylinder, which would be for high side, or travelling cylinder north, which would be for north reference. So you must ensure that these are selected here when looking at the travelling cylinder plot. Error surfaces. So we have three options for the error surfaces. We've got pedal curve, circular conic, combined covariance. Pedal curve is the default, and the warning type. So the option that we've got selected in the warning type drop down affects this warning section on the right hand side, and these warnings are the things which will be flagged within the anti-collision report, and if you have error ratio selected, these will also be flagged in your separation factor plot. So we have two options. Error ratio is just separation factor basically. So the default warning levels within the software are level 1 is 2, level 2 is 1.5, and level 3 is 1. And what this means is that any separation factor between 2 and 1.5 will be flagged as level 1, between 1.5 and 1 will be flagged as level 2, and anything below separation factor of 1 is flagged as level 3. This is totally editable. You can change these warning names to anything that you wish, and you can also change the ratio to anything that you wish as well. If we select rules based, we see that this gives us a couple of additional columns within the warnings box. So from the type, we've got drop down, and we have got three options. So error ratio is exactly the same as the error ratio that we had a moment ago, and this again is just our separation factor that will be flagged. We also have depth ratio. So within the depth ratio, you would enter a ratio in here, and you would enter a warning. If I just call this depth ratio, and what this does is this looks at the measured depth that you're running the scan, and it multiplies the measured depth by the ratio. It then utilises that value as the centre to centre distance, and if the centre to centre distance in the scan is less than this value, it will be flagged in the report. So in my example here, if I was to have a ratio of 0.1 and I was to scan at 100 feet measured depth, that would be 10 feet centre to centre distance. So if we were closer to any of the offset wells than 10 feet, it would flag this warning. You don't have to have any value in here for the maximum radius, but if you put a maximum radius value in, when this is reached, it then overrides the ratio, and it won't allow the centre to centre distance value to go above this value here. So in this case, when we get to 10, it won't get any further. If I leave this blank, it will just continue to use the ratio rule. The last option that we've got is we've got minimum centre to centre distance. So if we put a value of, say, 15 in here, and we say 15 feet limit. For this one, we don't put a ratio in, so we can leave this cell blank. And all that this does is this just means that any centre to centre distance against any of the offset wells, if it gets within 15 feet or less, will be flagged. So the main difference between the depth ratio and the minimum centre to centre distances is that the depth ratio, as you get deeper, the centre to centre distance limit value will increase. For the minimum centre to centre distance option, this is a fixed value the whole way. Just as a reminder, for the minimum centre to centre distance, we don't need a ratio, and for the depth ratio, we don't require a maximum radius, but if you put a maximum radius in here, the software will use it. We also have active tick boxes down the side, so you can check whatever warnings you want to be active, and you can of course have a mix of all three. For this example that we'll work through, or as we're looking at, we will just stick with the error ratio. Error output as sigma. So this is the sigma level that we're going to be outputting at. So this determines the level of confidence that we have in our Wilbur position, and the value that you enter here directly affects the size of the ellipses of uncertainty which are generated. The higher the value here, the more confidence you have, and therefore the larger your ellipses of uncertainty will be. This is just manually entered. 2 is the software default, but as a user you can enter this whatever value you wish. We have an option for do we want to include casings. It's just a simple yes or no option. If you have no selected, then include casings is greyed out. We can't do anything here. But if we have yes selected, then we can select do we want to add or do we want to subtract casings from our calculations. Turn that back to no. Errors calculated from surface. So do we want our errors to be calculated from surface or from the mud line? So if we're offshore, we can select to just start our calculation from the mud line, and onshore wells we can select from surface. The final anti-collision setting in here is the TC plot safety factor. So this is specifically related to the travelling cylinder plot. On the travelling cylinder plot, the errors on the reference well and the offset well are added together, and they are displayed on the offset well. And they effectively form the no-go zone. If you were to touch those particular lines, you would have a separation factor of 1, and anything beyond there is effectively classed as a no-go zone. What this value does is it allows you to add a safety factor to those ellipses that are generated. So if I was to say, for example, 1.2, this would give me ellipses that were 20% larger than, well, they give you a 20% safety factor, so they're 20% larger than the calculated values that would be used within the normal scan. We can take a look at this a little bit later when we look at the travelling cylinder plot, but for the purposes at the moment we'll just leave this as 1. This doesn't affect any other outputs at all, just specifically the travelling cylinder plot. So once you've entered your anti-collision settings at the operator property, you can hit apply. And now that we've got the anti-collision settings entered, the next important thing to consider is the plans and surveys in the database, as these are a representation of our wells, and any errors made here will make the anti-collision outputs invalid. So the first thing that we want to consider when inputting surveys and plans is the coordinate reference system and the surface locations. If our wells don't start in the correct place, then our outputs are not going to be correct. So the first thing that you'll do is, when you're entering your data, you want to check that you've got your mapping grid correctly selected. Mapping grid selected from this drop-down menu. And once selected, when you enter a grid easting or a grid northing, or a latitude or longitude, the corresponding values will automatically be populated based on the coordinate reference system selected. It's really important to double check that the calculated values match what's expected. And you want to check that at field, facility, and especially at well level, as this is the one that's going to have the most impact. Now at facility and well properties level, there is an option to enter a location uncertainty. And this is the uncertainty associated with the physical measurement of the surface location. Values that are entered here affect the ellipse of uncertainty calculation and in turn the anti-collision. So if you have these values that are entered here, If not, you would just leave them as 0. So when we physically enter a plan or a survey, you should also check the tie-on line, or the first line, and the last line within the plan. Check that your calculated values for the TVD, north, south, east, west, all tie in as expected, because again, if these don't tie in, specifically for your offset wells, which you may be pulling in from another source, if these don't tie in with the survey listing that you've been provided with, or with the offset plan that you've been provided with, then you're not representing this correctly within the software. So very important that when you pull this in, or when you manually enter the values in here, you check your top and your bottom lines tie in, and that will give you the confidence that your plan and your surveys are in correctly for when you're going to be running your scans. The next thing that we want to look at either plan or actual well level is the magnetics. So the magnetics are important because the values that are used here as the active magnetics are used as part of the ellipse of uncertainty calculation. And of course, this also has a direct effect on anti-collision. The software comes with IGRF 13 and WMM 2020 error models, and entering the date will automatically generate the declination, dip and total field strength. But if you are using any different models such as IFR, HDGM, BGGM, then these can be easily entered as user defined, and you can manually input the values. Again, if you are manually putting these values in, care should be taken that these have been input correctly, because any errors made here can have an impact on your anti-collision outputs. Again, make sure that the value that you want, because you can have several magnetics values in here, make sure the value that is appropriate is checked as active. So the final thing that we want to ensure is correctly selected is the instrument performance model, or the IPM. So the selected IPM is used by WellSeeker to generate the ellipses of uncertainty, and is very important that this is correctly selected, as the different error models can produce significantly different outputs. For a plan, the IPMs are entered at plan properties level, and by selecting the IPM cell, a drop-down menu will appear with all the available instrument performance models. For a survey, if we go to our actual wellbore properties, we can see the IPMs are displayed, but they are greyed out. So you can't, for a survey, you don't select them in the same place as a plan. So they don't get selected in the survey program. These are selected in the individual surveys themselves. So if any adjustments need to be made, this is where they're selected, and it will automatically populate in the survey program with the values. So all of the IPM models that are available within WellSeeker have been created in line with the Industry Steering Committee for Wellbore Survey Accuracy Guidelines. And you can see that there are quite a lot of options to choose from. So if we take a look at the Survey Tool Editor, which can be accessed via the Tools menu and Survey Tool Editor, it can also be accessed at Plan Properties level by selecting Survey Tools, or from the individual surveys themselves by selecting Survey Tools. And this opens up our Survey Tools Editor. And what this shows is, for the selected IPM, it shows us all the relevant coefficients that are used to generate the ellipses of uncertainty. It's very important to understand that when selecting this from the survey properties level, because a mistake a lot of people make is instead of selecting your instrument performance model from the drop-down menu, they select survey tools, select one in here, and think that when they hit apply and come out, that will be it selected. And this is not the case. This just allows you to access the survey tool editor itself. And in here, really, there are only a couple of things that you want to do in here. You'll be able to check the various coefficients that have been used for the selected error model. You can select a default survey tool. So in my case, I have MWD selected as default. And what this does is, it just means that if you go to run an anti-collision scan, so generate a report or open up any of the anti-collision plots, if you have your reference or any of your offset wells that do not have an IPM assigned by mistake, the software, when it's running the scans, will give you a warning and it will assign the default survey tool that you have selected. So in my case, it will assign MWD. You can, of course, assign something that will give you a much larger ellipse, like blind or unknown. Generally, when this flags up, you should go back, find the well in question, and change the IPM. Another option that we've got within the survey tool editor is the inclination only wells display vertical. So if we just have a look at an inclination only well, this well has an inclination only survey instrument assigned. We have inclinations, but we also have to, within the software, enter an azimuth. We don't have an azimuth with these readings, so we've just left the azimuth as 0. In this situation, if we look at the section view plot, this well has plotted as a vertical well. Even although we've assigned an azimuth, and even although we have inclinations, and because we have the inclination only error model assigned, it's plotting purely as a vertical well. If you do not wish it to do that, then again you can go to Tools, Survey Tool Editor. You can uncheck this option, hit Apply, and now when you open your section view plot, you can see that it's no longer plotting as vertical. This is plotting based on the azimuths entered. So in our case, it's just plotting north. There is a document available from Help, open documentation folder, inclination only IPM guidelines. So this is something that, if you wish, you can take a look at to understand a little bit more about this option. If I just go back in here and check this option again. So there are a few other things that I would like to mention about the IPMs. So it is possible to create your own IPM, and you would do that within the Survey Tool Editor. You can select Create New. You'll create your IPM file in here, and then it will be available from the drop-down menu, and you can select Edit, and you can go in and edit any of the relevant coefficients that are required. This is not something that most people will do. In most instances, if you require a new IPM, for example, if you have a gyro company that are running some gyros for you and you need the IPM for their specific gyro, in almost all cases they will supply you with an IPM file that you can use. So you wouldn't have to physically do this, they will give you an IPM file. Now the IPM files, if we go to Help, open Setup File folder, the IPM files are located in this folder. And as we mentioned, the software comes with a range of IPM models, but this is where you would add any new IPM models that you were sent. And in most cases, these will be ones that come directly from, for example, a gyro company. They can be put in here, and then when you open the software the next time, whatever's been entered in here will be available for you from the drop-down menu. Something else that I should point out is that within the software, we have the ability to import compass export files. If you pull in compass export files, you can select to import the survey tools. So any instrument performance models assigned within that EDM file will be pulled into the software and will be referenced. If that happens, then those new IPM files will be pulled into the folder that I've just shown you and will be available from your drop-down menu. So if you pull in a lot of compass files from a lot of different sources, you may find that you have a lot of additional IPMs in there. And in many cases, it can just be differences in naming conventions, but sometimes there will be additional IPMs in there, of course, with, for example, gyros. If in the compass import settings you don't wish to pull those in, then you can uncheck this box and it won't pull those ones in. So I've now gone through all the inputs and settings within WellSeeker that affect the anti-collision outputs. And it's important to remember that the output is only as good as the input. So it's vital that the things we've discussed so far are entered correctly to ensure you get a meaningful anti-collision output. When comparing the anti-collision outputs from WellSeeker against those from other programs, it's essential to ensure that the setup in both is identical. Any differences in the setup in either program will have an effect on the output and may adversely affect the comparison. We'll now take a look at some of the anti-collision outputs. So the first thing that we'll take a look at here is the anti-collision settings. So these are available via the Tools menu. You can select anti-collision settings from here or from the toolbar along the top. So this will open the anti-collision settings dialog. And most of the information or most of the settings that you enter in here are going to affect the report manager or the travelling cylinder plot specifically. At the top, we've got some interpolation information. We'll see when we start looking at the reports that one of the options in the reports is this interpolate. And every time you open the report manager dialog, you can enter the values. If you've got this information checked here, this will be populated every time you open an anti-collision report manager dialog. So this just saves you having to, if you're consistently running reports, making changes, running the reports again, if you set this up for a given interval, for a given depth range, to include final stations and stations, then it just means every time you open your anti-collision report manager dialog, these will be pre-populated for you. I just uncheck the depth range at the moment. You can also enter in here to limit anti-collision results. So by checking these boxes and entering a value, it will just mean when you run your anti-collision scans and you generate your report, you can limit these to any centre-to-centre distances, say within 1,000 feet or a separation factor of 10. Whatever you want, you can enter in here and that will affect your outputs. For our anti-collision results, we have a summary section within the anti-collision report which will give us our closest centre-to-centre distance, ellipse separation and lowest separation factor against each well. You can have these so that they don't sort, so this will just group these outputs based on each of the offset wells, or you can have it so that in there it will give you the lowest centre-to-centre distance to the largest, or ellipse separation or separation factor. And the one thing that's down here that specifically relates to the travelling cylinder, when you open a travelling cylinder plot, there are two references that you can utilise, either north or high side. You can select the default so that anytime you open the chart it will always reference the specific default. You can change this within the chart when you have it open, but this just means that every time you open it, it will give you the desired value that you want. So once you've entered this for the way that you like it to be, you can hit OK. Now, before we can use any of the anti-collision features, we need to ensure that we have at least one offset well selected. Otherwise, we'll get an error when we try to run any of the scans. To do this, we go to our Tools menu, Offset Selector. And this will open the Offset Selector window, and it will show a database tree with all the wells available to be selected as offsets. So in our case, we can see we've got some plans, or we've got surveys here. If there were plans, relevant plans in here, those could be selected as well. And you select the offset wells that you want. Very, very important to make sure that you have all the wells, the offset wells that you need to selected in here, because you cannot flag an issue if you have not selected the well to scan it against. So select everything that you need in here, hit apply, hit close, and if you try to run an anti-collision report, or if you try to open one of the plots and you don't have an offset well selected, it will flag an error. So it will then just remind you that you need to go in here to select this. So in our case, we have a plan open and we've got several surveys selected as offset. So we're now going to take a look at how to generate an anti-collision report. So we'll do this by selecting the Reports menu, Anti-collision Report, and this will open the Report Manager. And we can see that we have one anti-collision report template which comes as standard with the program. We can create new anti-collision reports just by selecting this option here, and that new report type will be saved in here and can be named appropriately. Reports can be printed out as PDF or Excel, and you can select from various options for the report columns and for the report options. Any changes that you make here can be saved and will be remembered just by selecting apply. So now that the template's been saved, every time you open this and you select on this particular report, the template will be exactly the same each time. Down the bottom left hand side of the report manager, we've got some interpolate information. Now, we talked about in the anti-collision settings, if you have information selected in that interpolate option, they will automatically populate in here. So if we have another look, if I was to select, for example, an interval of 100, go into my anti-collision report, this will be checked all the time. And that just means that if you're constantly making changes, trying to get your anti-collision to pass, instead of having to manually enter this information in here each time, it will always appear. And then you have to remember, if you want to deselect it, you would have to go into the anti-collision settings. But at this point, you can still manually adjust this to whatever way that you want it to be. We can put depth interval to and from. We can include the final station and the stations, and if it's a sidetrack, you can include the whole well path if you wish. You also have a couple of options down the bottom here where we can include separation factor plot or the ladder plot, and these will be included at the end of the report. And we'll hit create. And this is going to generate an anti-collision report with all of the relevant anti-collision information. So our sigma level, error surface, scan method, if we're including casings. We come down and we've got our anti-collision summary. So again, in our anti-collision settings, we have the ability to select if we wanted to sort the anti-collision summary. We've selected not to sort, and as a result, this has just grouped all the information for each well together. So the centre to centre, ellipse separation, separation factor. But if we'd selected to group these or to put them in centre to centre or separation factor order, it would just order these from the smallest to the highest. And then we have a further breakdown every 100 foot as we've selected for each of our individual wells. In addition to our anti-collision report, we have got 3 additional plots that specifically relate to anti-collision. We have our travelling cylinder plot, separation factor plot, and our ladder plot. So if we first of all take a look at our separation factor plot, and at the bottom of our separation factor plot we can see lines that represent the different levels that we have entered at operator level. So our warning levels, when we have error ratio selected in here, these are being visually displayed at the bottom of our plot based on what you've selected. When you open the separation factor plot, it will always have a range between 0 and 10 for the separation factor on the y-axis. As a result, for our 4 offset wells, we can only see 3 of these. If you want to increase this range, you can double left click on the chart and we'll increase this maximum to say 20. And now we can see all of our offset wells on here. I can also right click and select to put a legend on, and if you wish, from the chart properties you can also put well names on here as well, just so that you can clearly see which line relates to which offset well. Next plot we'll take a look at is the ladder plot. So the ladder plot plots the centre to centre distance for each of the offset wells versus measured depth. And we can use our scroll button on our mouse to zoom in to get a clearer view. We can drag and grab, or at the bottom we can grab and use the slider to see how far away each of our wells is at any given measured depth from the reference. Now the last plot that we'll talk about is the travelling cylinder plot. So this is our travelling cylinder plot, and there are quite a number of things that need to be considered when dealing with a travelling cylinder plot. The first thing, which I mentioned at the beginning of the clip, is that the scan method that we have selected at operator level should be travelling cylinder or travelling cylinder north. It's very important to understand that even if you've got 3D closest approach selected, 3D closest approach will allow you to plot values on here, but to use this plot correctly you really should be choosing travelling cylinder or travelling cylinder north. The big difference in terms of the way that it's plotted, travelling or 3D closest approach scans down the reference well against all of the offsets. The travelling cylinder, it scans down all the offsets against the reference well. So in our example, our travelling cylinder we're looking at the moment is north reference tool face, so we'll choose travelling cylinder north in the scan method and we hit apply, and you can see immediately it has made a little bit of a difference with the lines that have been plotted on here. So the first thing, and one of the most important things, is when using travelling cylinder you must make sure that the scan method is changed in the anti-collision settings. We'll hit apply and we'll hit close. Now to zoom in on a travelling cylinder plot, you do that by left clicking and dragging. You can see by doing this we're zooming in a little bit closer each time. And then once I'm zoomed into the scale that I would like to be at, I can put my ellipses on, and these will be displayed on the offset wells. And again, as I mentioned before, the travelling cylinder takes the error ellipse on the reference and the offset well, and it adds these together and it displays them on the offset wells themselves. Now, the best thing to do with this plot is to now look at it over a given depth range, and there's things that we can do to tidy it up and make it look a little bit better. So the first thing that we'll do is, by double left clicking on the chart again, we can make the errors the same colour as the series. So if we click on this, it then makes it a little bit easier to see which errors relate to which line, because these are effectively forming our no-go zones at any given depth. If we go back in here again, we will want to increase the plot frequency. So this is all related to the ellipses. So we're plotting these every 5 of our given interval. We're going to change this to 1, so the frequency is going to increase. We can see that although we've got errors on our offset wells, we don't have it on this red line. This red line represents the survey which is related to our plan, and in an ideal world this red line is going to be exactly in the centre. That is because up here in the travelling cylinder reference section there is a checkbox that says show errors on reference well. If I was to show those on, the plot would be very messy, and we don't want to see those in almost all cases, so we will uncheck that option there. While I'm showing you this section, I'll get rid of those first. You can also change from within the chart properties between north and high side toolface reference, and if we do that we can see that it changes the plots. Again, great care should be taken here because there is a different scanning method for each of these, so the reality is if you're going to change to high side you really need to change your scanning method at the same time. But for this we'll leave it as north and we'll leave it to plot. What we'll do now is, to try to make things a little bit clearer on here, we're going to look at using a range, a depth range here. So instead of plotting absolutely everything, we're just going to plot in on a certain range that's of interest. So if we look at our anti-collision settings, we'll go with this in the tools. I mentioned before that these settings not only affect the anti-collision report, but they also affect the travelling cylinder plot. So we have an interval of 100 selected here. If we were to put in a depth range of say 300 to 500, and if we hit OK, we'll see that we're now only plotting the depths of 300 to 500 on our chart. So it's made this a lot clearer and easier for us to see. What we can do now is, if we take an interval of, for example, 50, and we go into our chart properties, we can put on some depth labels. So we're going to plot measure depth. We're going to do label interval every 50. We've selected our ellipse plot frequency of 1, and that means that we will be plotting an ellipse every 50 feet because we selected 50 in our anti-collision settings. We'll also put tether lines on our labels. And if I zoom in just a little bit, and we'll make these a little bit larger, you can start to see that we've got our depths and we have got our no-go lines plotted for each of these. If we go in and we have another look at our properties, I mentioned at the start of the video as well that we have travelling cylinder plot safety factor. So if I was to change this to 1.2, we will add 20% to our ellipse sizes that we've generated here, and you'll notice that they get larger. So your no-go zone effectively gets bigger, giving you a 20% safety margin in there. And there we go. So that's the travelling cylinder plot. So that now covers the anti-collision reports and chart outputs. The final thing I want to introduce is the real-time anti-collision scanning. The first thing to understand with real-time anti-collision scan is that it's only accessible via surveys. It cannot be accessed via a plan. It's something that is used as the well is being drilled. So we can access this from the toolbar along the top, or from the Tools menu, Dashboards, Real-Time Anti-Collision Warnings. And that will open up our Real-Time Anti-Collision dashboard. So along the top we have got warning levels. We've got 4 different warning levels that we can select. And basically, as we're drilling the well and as we add new surveys, if any of these warning levels are breached, the warning will be flagged in the anti-collision results down the bottom. So we have a minimum distance to offset well. So at the moment, with this setup, if we get within 30 feet of any of our offset wells, we will get a warning. Maximum distance from the plan. If we get more than 48 foot away from the plan, we will get a flagged warning to tell us this. If we get more than 30 foot or within 30 foot of a lease line, then we will also get a flagged warning. And the minimum separation factor of the 4 warnings, this is the one that every time you open the dialog you will have to check this. But while the dialog's open, this will always stay checked if you make that selection. So here what we're saying is that when the minimum separation factor is less than 1.25, we want to see a warning as well. So notice when we check this option that we now have a few additional columns in here, specifically with the separation factor. The point of interest is always the last point in the survey. Now this could be a projection, or it could be a new survey as it's added, and I'll show you that just in a second. And then in the anti-collision results we can see first of all our reference well plan. So this would be the primary well plan, the principal well plan that has been selected. So here we can see we have a principal well plan, and we have our offset wells, and then we also have a lease line which has been shown up as well. For our well plan we can see that there's no separation factor, and the same for the lease line as you would expect. We have a sorting option up on the top right hand side here, and if we select that it will sort out our anti-collision results in the centre to centre distance, the closest or the lowest to the highest, and it will do the same for separation factor, or we can select to have none at all. And if I just use an example, here we can see that we're currently 16.58 feet away from our well plan. If I put our maximum distance from plan to 17, and if we add in a survey point, we'll just add in a completely false survey, we can see that immediately the point of interest is updated to be the last line in our survey listing, and we can see that our centre to centre distance has gone from being 16.5 feet to now being 128, and that is immediately flagged as greater than the maximum distance. This dialog, this real-time anti-collision dialog, can stay open all the time. So once it's open, it can stay open, it can be pushed to the background, put on a second monitor, but the idea is that this stays open as you're drilling your well, and as you add in new lines, this will update automatically. If I just show, if we put in a projection in here, append that to the survey, again we can see that the projection has immediately updated in here, and our centre to centre distance is now even further away than it was before. Just remove that, and if I remove this last line that we've just put in. The final thing to mention in the real-time anti-collision dialog is the real-time anti-collision email, which is accessed via the File menu. If you select this option, it will open an Outlook email, and that Outlook email will contain some information regarding the survey and the offset wells, and it will contain some attachments based on the options selected. So here we can see that we've got survey report in PDF and Excel. We've also got an Excel anti-collision report, and we'll look at those options in a second. Within the body of the email, we have got our last survey, we have got a bit projection, and we have got a couple of additional straight line projections as per the options selected within the real-time anti-collision dialog. We then also have the same thing against all of the offset wells. So we've got the last survey, bit projection, and then the additional projections. In the options menu, this is where you can select the setup for the email. So if this is checked, it will obviously automatically open an email when you select your option. If we have this option ticked, then the software will look at the surveys that we have in our survey listing, and it will say that the last survey is a projection. If you want to include survey reports, so we saw that we had a PDF and Excel as per our selection here. You can also choose text, TXT. Anti-collision report, you can attach PDF or Excel or both. And for the straight line projections, we had selected 100 and a 200 foot, but you can also include 300 or 400 foot or any selection you wish in between. That's just very quickly and easily just allows you to generate this email with all the relevant information that you require, so that you can send to whoever requires it that's maybe not on the rig site. That's us now going through the various anti-collision features within WellSeeker. We're now going to take a look at some questions. So I'll read out a question. If you press pause, try to answer the question yourself, and then press play to see the answer. So question number 1. At what level in the database tree do you access the anti-collision settings? So you access the anti-collision settings at operator level. Question number 2. When comparing the anti-collision outputs from WellSeeker against the output from other programs, what is important to remember? It's important to make sure that the setup in both programs is identical to ensure that you have a true like-for-like comparison. Even if you have one thing which is different, it can have, depending on what it is, it can have quite an effect on the output. So you have to make sure that everything in both programs is set up in an identical way. Question number 3. What anti-collision charts are available to view in WellSeeker? We have the separation factor plot, the ladder plot, and the travelling cylinder plot. Question number 4. Can you access the real-time anti-collision feature when the selected reference is a plan? No. The real-time anti-collision dialog can only be accessed when in a survey. If you're in a plan, it will be greyed out and will not be able to be selected. Okay, so the end of training exercise for this particular video is to create a database with a reference well and at least one offset well, and have a play with the various anti-collision features within the software. If at any point you become stuck, refer back to the video for a refresher. This now concludes our Well Seeker Introduction to Anti-Collision training video.